For number 7, what is the difference between the two values? The difference is that negative pi half is, let's say negative pi half, t is negative, and 3 pi, t is 3 pi half, sorry, 3 pi half, t is positive. Objective 2b, find the terminal point of t equal pi over 3. Notice that the whole circle is 2 pi, right? So pi over 3 is 1/6 of 2 pi. So you take 1/6 of mean multiplication. 1/6 times 2 pi is pi over 3. That's how you check. Now, on the picture on the right, they use the hexagon to find the terminal point of t equal pi third by dividing the unit circle into 6 equal parts. How do they determine, say, for example, I know that if you remember this from high school, you know this point, t equal pi third, is have a point with x equal 1/2 and y is √3/2. Right, we told that if the point is equal to that, we kind of remember it, right? But how do we come up with that? Well, this right here explain it to you how they come up with that using the distance formula. Right? So if I let the point in black right there 1/2 and come up √3/2, say I don't know anything about that, I'm gonna call that point P, right? So A and B is I'm trying to solve. I'm gonna call that point P, and I'm gonna call the point symmetric to the left of P is B. This point right here. The distance of BP is, remember the distance formula, you can remember the distance formula is equal y2 minus y2 minus y1 square plus what? x2 minus x1 square, right? So or square root of x2 minus x1 square plus y2 minus y1 square. It doesn't matter, it's the same thing, right? A plus b, b plus a. Here they take to find the distance of BP, they take a minus, so this one right here, minus a, so that's my x1, that's my x, maybe they call it x2, x2, and this is x1. You write it nicely, x2, x1, y2, y1, b is y1, right? So x2 minus x1, negative a minus a, and then square, plus y2 minus y1, b minus b square. Well, b minus b is 0, 0 squared 0. Minus a squared will be negative 2a. All of that square is equal to square root of 4a squared. And then you do the same thing for BPA. PA. A minus 1, right? X2. So this right, and then we do A, oops. A minus 1, all of that square, plus y2 minus y1, b minus 0, all of that square. Now you simplify. A minus 1, all of that square, you have to write out twice and FOIL it. You end up with a squared minus 2a plus 1, and then plus b squared. A squared plus b squared is 1, right? Because that's your xy value and it's on the unit circle. Remember, x squared plus y squared equal 1 if the point is on unit circle, and AB is on unit circle. So a squared plus b squared equal 1. This part right here equal 1. Minus 2a plus 1. Simplify, minus 2 square root minus 2a plus 2. The distance of BP is equal to the distance of PA. So you set the two guys equal to each other. Square both sides like this. Square and square root cancel. So just 4a squared minus 2a equal minus 2a plus 2. Move everything to the right. I think they divided by 2 first. They kind of divide everything by 2. Now move everything to the left. Sorry, move everything to the left because it's quadratic. You want to solve for that. We end up factoring 2a minus 1, a plus 1. This implies either 2a minus 1 equals 0, or a equal 1/2, or a plus 1 equals 0, or a equal -1. Since a lies in quadrant 1, we choose a positive value, so we choose a equal 1/2. Well, we found a, right? We found a. Now we substitute into the equation, the unit circle equation. Remember, a squared plus b squared equal 1. Right? In order to find b, without further ado, I don't want to repeat myself here. It's just arithmetic. B is plus minus √3/2. But since b is in quadrant 1, b is, remember, it represents y, right? Quadrant 1, x and y both positive. So we choose b equal √3/2. Finally, the terminal point determined by t equal pi3 is 1/2 and √3/2. That's how we come up with that point. Okay? And from this point, we come up with the rest. Same thing, how to find pi/4. I'm not gonna. You can read it yourself. The explanation is pretty detailed. All right, let's do number 9. Given the unit circle below, use symmetry to find t and the terminal point determined by t for the point A, B, and C. So given the point t equal pi, well, the arc length t equal pi/4, the point right there is √2/2, √2/2. I want to find A, B, and C. Well, let's find t first. Let's find t first for each of the points. So basically I go, so right there, if I stop right there, if I stop right here, that's t equal pi/4, right? But if I keep going all the way to point 8, then how much more distance did I went through? Remember, this one right here is pi/4, right? This is pi/4. This is another pi/4. So basically, pi/4 plus pi/4 plus pi/4 plus pi/4. So pi/4 plus pi/4 plus pi/4 3 times, so that'll be 3 pi/4. So t right there is 3 pi/4. I would say t of a, right? This is called t of a. Maybe it's red. No, I think blue's good. What about t of b? So right there, point 8 is 3 pi/4. And how many more did you go? Remember, from here to here, that's another pi/4. Here to here, that's another pi/4. So 5 pi/4. So t of b And then C, right? Then for part C, of course, we always start here, okay, guys? We always start right there. I just kind of lazy not to mention the other part because it's kind of scanned by point A and point B. So so right at point B is pi over 5 pi over 4. And how many more did you go? You go another pi over 4 and another pi over 4. So 5 plus 1, that's 7 pi over 4, right? So T of C is 7 pi over 4. Now, there's a more than one way to explain this problem. Okay. I think on my notes, I kind of put it differently. There's a different way of me doing this. What about the point? If you start out at t equal pi over 4, the point is root 2 over 2, root 2 over 2. By symmetry, A is what? Well, x is going to be negative, right? Because it's on the left-hand side of the origin now. So x is going to be negative 2 over 2. But y is still positive because in quadrant 2, it's still positive. Similar would be the point lie in quadrant 3, so x, y both negative. So be negative 2 over 2, negative 2 over 2. Now this is symmetric, so the absolute value of the point is equal. All you have to do is change the sign. And then point C is lying in quadrant 4. You're going to have a positive x and a negative y. Number 10, that's what you try. It's a similar thing. You can try 11 on your own. All right, I think here is the part where students got confused. Reference number. You know what? I never really use these picture. What I use is the definition that they give me right here. All you have to know is that the reference number, t prime, associate with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. Remember, it's the shortest distance between the terminal point and the x-axis. That's all you have to remember. I really don't remember these because I forget, right? Once I'm done the class, I'll forget. So might as well just using the definition so that way you don't ever forget. 12a, they want you to sketch the value t on a given unit circle, then find the reference numbers and terminal point determined by t. Make sure the sign of the terminal point agree with the quadrant. Lead answers exact. So t is negative pi over 3. Negative pi over 3. You go clockwise, right? You got the negative angle. So that is t equal negative pi over 3. Remember, I know I keep saying this. Now we want to find the reference number t prime. It is this shorter distance. Remember, distant. Therefore, what? Therefore, it cannot be negative, right? It's the shorter distance between the terminal point and the x-axis. If you look at this picture, what is the distance? It's shorter distance between the terminal point and the x-axis. Well, this distance right here, that distance right there, that's the shorter distance that you go from the terminal point to the x-axis, right? So that distance right there is what? Pi over 3. I'm talking about distance. I'm not talking about direction, right? Direction is negative pi third because you're going clockwise, but the distance is pi third. Right? So that would be t prime. Right down here, t prime equal pi over 3. Oops. 12b, t is negative pi over 4. Let me show you the unit circle so that you can you know what, we can construct ourselves, it doesn't matter. Let's divide the unit circle into some equal part. So we know that right there, this distance right here, that's what? That's pi over 4, right? Another pi over 4, because pi over 4 plus pi over 4 is pi half, right? Keep doing that. Another pi over 4, another pi over 4. So how many pi over 4 we did? 4, right? 1, 2, 3, 4. And then another pi over 4. So that's 5 pi over 4 is right here. We use blue. That's 5 pi over 4. That's t equal negative 5 pi over 4 because we do clockwise. All right. Again, I want to find t prime, the reference number. Same thing. The definition, right? It's the shorter distance between the terminal point to the x-axis. And that shorter distance is, that's a weird red, I believe. And that short distance is right here. This distance right there. What is that distance? Pi over 4. To see how easy that is? All you have to remember is the short distance between the terminal point and the x-axis. Negative 5 pi over 6. Let me show you another trick of me determine the angle using radian, right? Well, you can change it into degree, right? But let me just show you a trick. I don't know what is, it's really difficult for me to visualize how much is negative 5 pi over 6. But what I know is negative 6 pi over 6. Don't write that down. Right? Well, negative 6 pi over 6 is the same thing as what? Negative pi, which is this distance right here. So negative 5 pi over 6 is slightly less than, right? If you divide this half circle into 6 equal parts, right? So negative 5 pi over 6. So maybe roughly there. T equal negative 5 pi over 6. Does that make sense? That's how I do it. All right. All right, now I want T prime. Again, T prime is the shorter distance between the terminal point, which is the red one right there, to the x-axis. So that little itty bit right there, that's my T prime, right? The distance of T prime. So T prime equal what? 6 pi over 6 minus 5 pi over 6, right? Distance, it cannot be negative, remember? So we pi over, sorry, it's over 6 over 6. All right, let's try some more. Sketch each value of t on a given unit circle, then find the reference number t prime and terminal point determined by t. So I know that given t equal 9 pi over 4. Now, if I want to rewrite this, it's the same thing as what? 8 pi over 4 plus 1 pi or just pi over 4, right? 8 pi over 4 is the same thing as 2 pi. So basically, this is what you do. You go twice around. I'm sorry, you go once around, and then you end up at one more, and then one more, and then one more. Into a circle. You go once around, and then a little bit more. Pi with 4 more. So you end up right here. So what is the distance? What is t prime? What is t prime? That distance right there, which is pi over 4, right? Maybe I'll write like a t equal 2 pi plus pi over 4. So that little bit distance right here, t prime, equal pi over 4. So t prime equal pi over 4. What is the point? What is that point right there? T equal 9 pi over 4 is root 2 over 2 comma root 2 over 2, right? Next, t equal 19 pi over 6. Same argument, t equal 19 pi over 6. I would recommend you split into something that, into an even, if you can, try to even number of you going around circle, say 2 pi, 4 pi, 6 pi, or 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 odd, right? Like 1 pi, 3 pi, 5 pi. 19 pi divided by 6 is the same thing as what? I can split into 18 pi divided by 6 plus pi divided by 6. 18 divided by 6, that's 3 pi plus pi over 6. All right, so you go in 3 pi. 1, 2, 3, and pi over 6 more. Right there. So t equal 19 pi over 6. And t prime is the shorter distance between the x-axis and the terminal point. So that will be pi over 6, right? That distance is pi over 6. See how easy it is? You don't have to remember anything. All you have to remember is the formula. I'm sorry, the definition. Why don't you guys try C? Just pause the video and try C. T equal negative 19 pi over 3. Here the same thing is negative 18 pi over 3 minus pi over 3 equal 18 divided by 3 is negative 6 pi minus pi over 3. 6 pi, that's 3 times around the circle, right? 1, 2, 3. And then, oops, sorry, I should have go clockwise. My bad, because the negative angle. 1, 2, 3, right there. 3. And then another negative pi over 3. Right, like that. So 3. And the reference number is this itty bit, which is t prime equal negative pi over 3. Oh, I've been forgetting to calculate the point. 13b, the point will be, if you look at unit circle, the point will be negative root 3 over 2, comma 1, negative 1/2. And for C, the point is negative 1/2. Sorry, the point is positive 1/2. 1/2 negative root 3 over 2. All right. Okay. Now if they don't give you they don't give t in term of pi anymore, they give you t in term of radian, right? Remember, pi is equivalent to 3.14, right? So if I would have split this half circle into roughly 3 equal half, roughly, I said roughly. So that would be 1 radian right there. So this little bit right there, that's 1 radian, 2 radian, 3 radian. And that little bit right there left is 0.14, right? Now t equal 1. T equal 1 is t right here. That t equal 1. That's this right here. What is t prime? Well, the shorter distance between the terminal and the x-axis. So it's also t prime, right? So t prime equal 1. How do I find x? Y? Well, x is the cosine of t, right? X equal cosine of t, and y is plug in t is 1. So x equal cosine of 1, which is roughly 0.5. Y is y is size of 1, roughly 0.8. Okay, so that point right there is 0.5 times. Now you can check if your work is correct using the equation of a unit circle, right? X squared plus y squared is equal to 1. X squared is 0.5 squared plus y squared is 0.8 squared. And it is roughly equal to 1. Right? Civic part B, t equal negative 4.2. Negative, so you're gonna go clockwise, right? So from here to here, you know that from here to here, right there, that's what, 3.14. 3.14. You want, well, negative 3.14 to be exact. You want negative 4.2. So how many more you have to do? Let's see. If you take 4.2 minus 3.14, you're gonna go 1.06 more. 1.06. So roughly 1. So 1 radian. So here, and then 0.6, so roughly here. So this is negative 4.2. That's t equal negative 4.2. What is my t prime? Again, it's a shorter distance between the terminal point and the x-axis. So that's right there. 2 minus 3.14 equals 6. And to find x and y, you do the same thing. X is cosine of negative 4.2. Y is the cosine of negative 4.2. 0.9. Number 15. Suppose the terminal point determined by t is the point 3/5 and 4/5 in quadrant 1 on the unit circle. Find the terminal point determined by each of the following. A equal negative t. Well, negative t. Let me determine the point first. Let me determine the point 3/5 and 4/5. So I'm going to divide this into 5 part here. 2, 3. 1, 2, 3, 4. No, good. 1, 1, 2, 3, 4, 5. Wait. 1, 2, 3. 1, 2, 3, 4, 5. All right, 3/5. 3/5. 1, 2, 3/5, and then 4/5. Right there. Perfect. Right. 3/5, 4/5. So that's T. That's the little black point right there. That's T. I don't know what it is, but it's T. I don't know what the. So let me do this. That's right there. That's T. That's T. I want negative T. So all you do is you go back. You go back like that. So that's right there. That's T prime. I'm sorry, negative T. Well, by symmetry, what is the point at negative T? It's going to be, you still have a positive X, negative 4/5. Again, this point right here is 5/5, 4/5. Pi minus T. Pi minus T. Pi, how much is pi? Oh, by the way, this is T. I gotta remember how to shade T. So that's T. Pi minus T. Pi is this much, right? The one I highlight in yellow. That's pi. Minus T. So minus this much by symmetry, right? So minus that much. So what is so this right here? So this point right here in blue, that will be pi minus T. I hope you get that. Right? So what the point pi minus T? By symmetry, you have a negative X, negative because in the second quadrant, negative 3/5, positive 1. C, pi plus T. T, 3/5, 4/5, pi plus T. So pi is this much, plus another T distance. So plus another T like that. There you go. Now you have, oops. Now you have pi plus T, right? The point is both negative, right? Because it's in the third quadrant. Negative 3/5, negative 4/5. 4 pi plus T. 4 pi is you going twice around, right? Plus T, 4 pi is you going twice around, once around, two's around. 4 pi plus T. And you go back to the same point, right? This point is 3/5. 4/5. Number 16, suppose the terminal point determined by T is the point 513 and 1213 in quadrant 1. I'm just gonna approximate, right? 513 right there and 1213 right there. And this right here, that is T. Find the terminal point determined by pi half plus T. Pi half plus T. Pi half is this much plus another t distant, like that. So that right there, that's plus t. And the point is what? Now, it's not symmetric anymore. If you look at this, right? It's not symmetric. Excuse me.